Okay, I'm Riley Madison.
And I'm Bailey Shoup. And we are here to present CP1 MP7. And MP7 is the look for and make use of structure. So our first example is an elementary level, and it is if you multiply 15 by 9. And so here I set up for 3 different structures, and on the first structure it is 15 times 9, just like the normal way. And the second structure is when you pull out the tens and the ones out of your first equation, so or the first side of the multiplication problem, so 15, which would be 10 plus 5. You have 1 tens and 5 ones, and you multiply that by 9 after you had added the 10 and the 5 together. And then the third one is 10 times 9, and then you would add 5 times 9. So you'd multiply the 10 times 9 and then the 5 by 9. And when you multiply each of those together, and then no matter how you multiply them, you're going to get 135 as your answer. So here I wrote that the students will be able to multiply 15 by 9 by looking at the place values of the structure while applying the distributive property in the last one. Elementary level students should be able to add and multiply numbers by applying their place value skills on how to decompose the numbers into their correct place values of hundreds, tens, and ones by using horizontal and vertical forms. You can do this either horizontally or vertical. It just depends on how the student likes it or what best fits your class.
And then we had the college level example, and I took this from just the ACT website. And so the example was, what is the value of x when 2x plus 3 equals 3x minus 4? So with this problem, the main structure is basically to get all the x's on one side and then the rest of the numbers on the opposite side. And then once that is done, it becomes 7 equals 1x. And then after you divide both sides by 1, it's 7 equals x. So the answer would be 7.
Look for and make use of structure, the definition. And so mathematically proficient students look closely to discern a pattern or structure. And I bolded mathematically proficient students because if you're not mathematically proficient, you won't be able to do this. So that only applies to people that understand math at a high level. And they recognize the significance of existing line in a geometric figure and can use a strategy of drawing a line for solving problems. And then the third definition is they can step back for an overview and shift perspective. And then the last one is they can see complicated things such as some algebraic equations and line objects, or as being composed of several objects. So here's like where you can apply many different structures into just anything in the math. It doesn't have to be like one thing.
And then we had our SIOP model. For our lesson preparation, we said that we would inform the students of the lesson's objective, and then we would provide problems at the student's level. And then for building backgrounds, we would be working with various factors, including numbers, mathematical operations, and key vocabulary. For comprehensible input, we said that we would be grouping similarities as well as understanding and recognizing symbols along with their meanings and number representations. And then for strategies, we said that we would be using problem solving and computational skills and operations to find the answer. And then for interaction, we said we were providing students with examples including the use of math manipulatives and visual representations.
And then we have the SIOP model continued. the practice and application, and that is have students work through real life problems in order to build understanding while working alone or working with others. And then we have the lesson delivery, which is showing examples, giving valid objectives, and scaffolding more difficult problems. And I think that this is relates back to what we did on our discussion board with scaffolding. You can build up a problem and give them the hints on how to get there, and then they can apply their own knowledge to get there. So it kind of goes back to our reflective. And then the review and assessment, and that is have students lead in showing what they have learned through explaining or through explanation by working through problems. Later assessing the whole class on what they have learned. So maybe have like your students get together with their classmates and their shoulder prodders or whatever you guys use, and ask them what they learned and to share with that partner, and then you can bring them back as a class and have them overall talk about what they have learned.
And then we have our resources. Back to the college example, I went onto the ACT website and I went to the math area, and there were a lot of different examples that we could have used. But I think the one that we chose was probably the closest and best that related to the MP7.
And then the Common Core state standards. This is just, it gives you an overall view of like what the math standards are for each grade, and how to apply them, and how to make sure that your students fully know the standards to pass the test, the standardized test. And then we did the flip book, and the flip book is designed by a lady with Melissa Hancock, and she is a K-State professor, and she designs the flip book of math and the Common Core standards. And so every Common Core standard's listed under that. And so first grade, that's where we found ours. It was everything was listed, and so they have like first, second, third, fourth, and fifth. And so the flip book shows like examples and like other strategies to use. So I think that the flip book was very, very beneficial, because it allowed teachers to figure out the different ways that you can teach stuff, rather than just like the Common Core standard way, or like New York math, or yeah. So that is our presentation. You can stop it.